guys' other review when it comes to trigonometry. Okay, so for question number one, now again, let's just remember, you guys, we have this acronym called SOHCAHTOA, which helps you to remember sine of theta equals opposite over hypotenuse. Cosine theta equals adjacent over hypotenuse. And lastly, tangent of theta, you guys, is opposite over adjacent, right? Okay, so you guys have that. Now, to find cosine, we are in the perspective of this angle, and cosine, you guys, is the adjacent and the hypotenuse. So all cosine is here, you guys, is 12 over 20. Now remember, if you can simplify a fraction, you do so. So 3/5 would be your guys' answer for that one right there. Okay, 3/5. Now let's take a look at the let's take a look at the next one, right? So for tangent theta, so you guys, here's theta, yeah. Tangent is opposite over adjacent. So opposite over adjacent in this case, you guys, is 4 over 4, which just simplifies to 1, right? That just simplifies to 1. Okay, here's theta, right? So if we're trying to find sine theta, that's just opposite over the hypotenuse, right? So opposite's 4 over 21, hypotenuse is 25, right? Can't simplify 4 over 25, so that's all you guys can do in terms of that simplification. Sine of theta. So sine is opposite and over hypotenuse, so we're going to have 15 over 17. And that can't simplify at all. Okay? All right. Number 5. Okay, so for number 5, you guys, we're finding side lengths. So same deal, we gotta use trig. So here's our angle, right? Angle perspective. We're trying to figure out what the 15 is. So the 15 is opposite, and the x is the hypotenuse to angle 41. There's only one trig function that uses opposite and hypotenuse, you guys. I'm gonna retrieve our SOHCAHTOA for us. Okay, there we go. Okay, so for number 5, you guys, it's sine. Sine is opposite over hypotenuse, so sine of 41 equals to opposite over hypotenuse. So to solve for x, you guys, we're going to put sine 41 over 1, and we cross multiply. X sine 41 equals to 15 times 1, which is 15. And then to isolate the x, you guys, we divide sine 41 away. Cancel. And this is what we're going to put in our Desmos calculator. So I need to do that for us, Kate. So here's all these. Let me delete all these. Okay, so we're going to utilize our Desmos, yeah? Okay. Please remember, everyone, yeah, you need to make sure that this is highlighting degrees, right? You need to make sure this is highlighting degrees. Okay, so we got 15 divided by functions sine of 41, right? Round it to the nearest tenth, so that's going to be 22.9, right? It's going to be 22.9. Okay, round it to the nearest tenth. Number 6. Okay, in the perspective of this angle, this is the opposite, this is the adjacent, right? So the only one that uses opposite and adjacent, you guys, is tangent. So, that's a highlighter. Tangent of 48 equals to 12.2 all over x, right? Put this over 1, and then you guys cross multiply. X tan 48 equals to 12.2, right? 12.2 times 1, you guys, is 12.2. And then to solve for x, we divide both sides by tan 48. Cancels. And we got, okay, I don't know. Okay, there we go. X equals to, okay, well, so this is the thing we need to plug into Desmos. So 12.2 divided by tangent of 48. So now be careful, right? So the 9, you guys, if you look at the 8, that means we need to round the 9 up. But then if we round the 9 up, you guys, that becomes 10. So that's 0. Carry the 1 over, so that should be 11. Round it to the nearest 10th, right? So that should be your guys' 11. Okay? This one right here, number 7. In the perspective of that angle, this is the adjacent right next to, right? And this is the hypotenuse, right? So adjacent hypotenuse, guys, that is cosine. So cosine of 47 equals to adjacent over hypotenuse. Put this over 1, and you guys, we cross multiply. X cosine 47 equals 16. Divide both sides by cosine 47, right? Cancels. So this is what we're going to put into Desmos, and once we put that into Desmos, we get 16 divided by cosine 47. We get 23 point, wait, 7, 23.5, oops, 23.5, right? Round it to the nearest 10th, right? Round to the nearest 10th. Okay, number 8. We have this angle, yeah? So adjacent, this is hypotenuse, and the perspective of that angle, right? So it's another cosine, right? So cosine of 28 equals adjacent over hypotenuse. Put this over 1, and you guys cross multiply, right? Oops, equals cross multiply. X cosine 28 equals to 10, and then divide both sides by cosine 28. Cancels. So 10 divided by cosine 28, we get 11.3. 11.3 as our final answer. Okay. All right, now for this next set of problems, you guys, okay? So in this next set of problems, it says you guys need to find an angle. So when you guys find an angle, this is where you gotta utilize your inverse functions. So sine inverse, cosine inverse, and tan inverse, okay? So for this one here, you guys, here's the angle. From that angle perspective, 2 is the opposite, 5 is the hypotenuse, right? Now, you guys have to use your trig. There's only one trig function that uses opposite and hypotenuse, and it is sine. So sine of theta equals to opposite over hypotenuse. To solve for theta, you need to get rid of the sin words. You have to do sine inverse to both sides, because these will cancel. And we'll have theta equals sine inverse of 2/5. We put sine inverse of 2 divided by 5, you guys, in the calculator. Round that to the nearest tenth, so that's 23.6 degrees. 23.6 degrees. Okay, number 10. We have this angle perspective, right? So 10 is the adjacent, 14 is the hypotenuse. We have to use cosine, right? So cosine is adjacent over hypotenuse. So to solve for theta, we have to do cosine inverse to both sides. These cancel. So theta, you guys, equals cosine inverse of 10 over 14. So we got cosine inverse of 10 over 14. And we get that, which is 44.4. Wait. Is that right? 10 over 14. Oh yeah, 44.4. Sorry, I keep on looking at the wrong one. 44.4 degrees. Okay. Alright. Let's look at number 11 and 12, okay? Number 11. We're in this angle perspective. 15.2 is the opposite. 15.6 is adjacent, so we're going to be using tangent. So tangent of theta equals to opposite over adjacent. And then to isolate the theta, you guys, you need to do the tan inverse to both sides. So theta equals to tan inverse of 15.2 over 15.6. We duke that out in our lovely decimals calculator. Tan inverse of 15.2 divided by 15.6 for 44.25. Round that to the nearest tenth, so we get 44.3 degrees. Okay, number 12. So we have this angle perspective, yeah? This is the adjacent right next to, and this is the hypotenuse, right? So that is cosine, you guys. So adjacent over hypotenuse, and to solve for theta, we need to do the cosine inverse to both sides. Theta equals cosine inverse of 6 over 15. Put this on our lovely decimals calculator. Cosine inverse of 6 divided by 15, and you guys get, round it to the nearest tenth, 66.4 degrees. Okay? Alright, so we will come back to our decimals calculator later. Now let's get to our 30, 60, 90 on our 45, 45, 90 degree triangle. So when you guys solve for the 30, 60, 90, you need to write down the ratios, right? The 30 is x, 60 is x rad 3, and 90 is 2x, right? Now, I think you can all agree the one across from the 60 we know is 6. So that means this one is equals to 6. To solve for x now, we need to divide both sides by rad 3. Cancel. So we got 6 over rad 3, you guys. And to rationalize that, you cannot have a denominator in the radical. We need to multiply top and bottom by said radical. So 6 times rad 3 over, okay, you guys, rad 3 times rad 3 is just 3. Because the square root of 9, you guys, is just 3. You can simplify 6 over 3, you guys. 6 divided by 3 is 2, and you guys still keep the rad 3. Okay, so we finally solve for x. So then, once you solve for x, just plug it into all the other ones. So we know this one's 2 rad 3, and we know this one is 2 times 2 rad 3 for 4 square root 3. Okay, so the one across from the 30, we know it's 2 rad 3. So we know C is 2 rad 3. And the one across from the 90, we know it is 4 rad 3. Okay. Okay, we got the 45, 45, 90 triangle. So the ratios are x, x, and x radical 2, right? So in this problem, they give us the one across from the 90. So we know this one's equals to 8. We need to solve for x, so divide to both sides by rad 2, right? So now remember, you cannot have a radical in the denominator, so multiply top and bottom by rad 2. 8 rad 2 over, you guys, rad 2 times rad 2 is simply just 2. Because square root of 4 is just 2. 8 divided by 2, you guys, is 4 rad 2. So that's our x, and we both know, or we all know, both of these are just 4 rad 2 then. So 4 rad 2, 4 rad 2. Okay? Alright, 15. So we got a 30, 60, 90, right? X, x rad 3, 2x. Now the side length we do know is the one across from the 30, so we do know that this 30, the side length across from 30 is 3. So we know x is equal to 3. Perfect. So then we plug in that into the rest. 3 rad 3, 2 times 3, which is just 6. So again, the one across from the 60 is here, so we know that's C. So we know this one's 3 rad 3. And we know the one across from the 90 is this one. So we know that that is 6. Okay, You guys are gonna have to remember those ratios. Okay, now let's get to our word problems, yeah? Okay, when you guys start these, right, you need to draw a right triangle, right? Because we're still using trig. Trigonometry is utilizing a right triangles, okay? Okay, Brian's kite is flying above the field at the end of a 65 meters of string. So you guys, if this is the kite, here is the string, right? There's the string. The person is here, right? Flying said kite. Okay, the angle of elevation to the kite measures 70 degrees. You guys, the angle of elevation is the angle formed with the ground. It's the angle formed with the ground. So it's this one right here. So we know this is 70. How high is the kite above Brian's head? So you guys, the height of the kite would then just be there. So you have that triangle, and now you guys can solve using your trig. In the perspective of that angle, this is the opposite side. This is the hypotenuse. We're going to be using sine. So sine of 70 equals opposite over hypotenuse. Put this over 1, and you guys cross multiply. X times 1 is x. 65 times sine 70, you guys, is 65 sine 70. And because x is already isolated, perfect. This is going to be what we need to put into our Desmos. So let's whip out our Desmos for us. And I am going to input 65 sine of 70. Round it to the nearest tenth, you guys, right? Round it to the nearest tenth. So that is going to be 61.1 meters. 61. Do not forget the units, right? Do not forget your guys' units. Okay, let's look at this one, right? Sorry. Here. Okay, so an airplane is at an altitude of 1,200 meters. So you guys, altitude means how high it is off the ground. So we know it's 1,200. And here's our lovely plane, right? There's our plane. Okay, the angle of depression. Okay, I already know when we do angle of depression, it's the angle formed with the ceiling. So you need to draw the ceiling, right? And it's going to be in this corner outside the triangle. Now remember, angle of depression is the same thing as the angle of elevation. So it's the same thing as that angle right there. Okay. Now it also reads, right, the angle of elevation to a building on the ground. So this is looking at a building on the ground. So you guys, the building is right here. Find the distance from the plane to the building. Okay, you guys, the distance from the plane to the building. You want to find this length right here. So in the perspective of this angle, again, this is opposite and hypotenuse, so this is another case of sine. Sine of 28 equals to opposite over hypotenuse, right? Put this over 1, and you guys cross multiply. X sine 28 equals 1,200, and you guys divide both sides by sine 28. Cancel. And this is what we need to put in your guys' Desmos calculator. So one last push. One last push. So we got, got this. 1,200 divided by sine of 28. And we got 2,556.1 meters. And don't forget your guys' units. Okay, so hopefully this helps you guys out. Study hard and good luck on your guys' quiz, okay? Alright, good luck everyone. Peace.